Welcome, my holographically projected personnel. I'm your two-dimensionally encoded orator, and you're listening to a special science break edition of the Multiverse Employee Handbook. Today, we're unpacking the holographic principle. Ever wondered if our universe is just a giant cosmic hard drive? Stick around. Now, you might be thinking, that's all well and good, but what does it mean for my day-to-day life in this interdimensional corporation? Well, in 2015, an experiment at Fermilab provided some evidence supporting the holographic nature of space-time. But here's the kicker. The holographic principle isn't just about information storage, it's also about the nature of gravity itself. So the next time you're struggling to fit all your files into your office, just remember, you might be able to store them on the surface of your desk instead, and that same principle might explain why you're stuck to your chair. In fact, let me tell you about our interdimensional archives department. They've started encoding all our multiverse branch records onto the surface of a small black hole. It's reduced our storage costs by 99.9%, although retrieving specific files can be a bit tricky. Last week, Johnson from accounting tried to access last year's budget and accidentally pulled out the entire history of a universe where the Pythagorean theorem never caught on. Needless to say, the numbers didn't quite add up.
Wait, what?
But wait, there's more! The holographic principle isn't just a standalone cosmic curiosity, it's deeply connected to string theory, that darling of theoretical physics that suggests everything is made up of tiny, vibrating strings. In 1997, Juan Maldacena proposed the ADS/CFT correspondence, a realization of the holographic principle that linked string theory to quantum field theory. Now, I know that's a mouthful, so let's break it down. ADS stands for anti-de Sitter space, a hypothetical universe with negative curvature, while CFT stands for conformal field theory, a quantum field theory with special symmetries. Maldacena showed that a gravitational theory in ADS space is equivalent to a CFT on its boundary. It's like saying that everything happening in your 3D office building can be fully described by the 2D graffiti on its walls.
Awesome.
This correspondence is a concrete example of the holographic principle in action and has become a powerful tool in theoretical physics. However, it's important to note that while the ADS/CFT correspondence supports the holographic principle, it doesn't directly prove that our universe is a hologram. Our universe, unlike the one in this model, isn't ADS space. It's more like your expense reports, constantly expanding. One of the most exciting implications of the holographic principle is its potential to resolve the black hole information paradox. This is the puzzle of what happens to information that falls into a black hole. The holographic principle suggests that this information might be preserved on the black hole's event horizon, like the world's most extreme filing system. It's as if everything that falls into the office shredder isn't actually destroyed, but just gets really, really compressed. Now, it's worth noting that while the holographic principle is a fascinating and potentially revolutionary idea, it's not without its critics. Some physicists argue that we don't yet have enough evidence to confirm that our universe is truly holographic. Others point out that applying these ideas to our actual universe is still a work in progress. And on that mind-bending note, we'll wrap up our science break. Remember, the next time you're staring at your computer screen, wondering where all your storage space went, just think. you might be looking at a microcosm of the entire universe. This is your two-dimensionally encoded orator, signing off. Remember, in a holographic universe, it's not the depth of your experience that counts, but how well you project yourself.